All right, so to start off getting ready 3 here, we're looking at some possible functions. We're trying to determine if the relationship is a function or not. So what we have to check for, and right here's the definition, is in order to be a function, each domain value can have only one range value paired with it. So each x has to have exactly one y paired with it. So in number 1, we have a little table here with 4 points listed in it. Since each of these x values are different, then there's no way that any one of them is paired with 2 different range values. So therefore, this is a function. And the way we justify that, or give the reason for it, is we just state the definition. Each domain value, or domain element, or x value is paired with exactly one range value, or y value, or range element. Okay. You'll write that statement many, many times, so find something you're comfortable with and stick with it. So number 2, now I'm looking at points on a graph rather than in a table, and there's 2, 4, 6, there's 7 points here. Would any of them assign one single x value to multiple range values? And the answer to that is yes. Right here, these 3 points would each have an x value of 3, but they're each assigned a different y value. So this one is no. It is not a function. And our reason is some domain values, or domain elements, or x values have multiple or more than one range values. And it's always helpful then to give an example. My example I saw there was I have 3 assigned to 20, 3 is also assigned to 30, and 3 is also assigned to 40. It would be just as informative to notice that here the x value 4 is assigned to 30, and it's also assigned to 50. So you wouldn't need to list all of those, but if you have just 2 points that have the same x values but different y values, same x values, different y values, then it cannot be a function. Okay. So number 3, each x value is paired up to exactly one y value. Now, some of these y values repeat, but that's totally okay. That does not violate the definition or the requirement for a function. So this one is a function. Again, we write our definition really as our reason. So each x value is paired with exactly one y value. Number 4, and maybe you're piecing together here what you're really looking for in a table is, do any of your x's repeat? So in this one, I see the 4 there twice. Once it's assigned to 18, next time it's assigned to 21. Well, that's definitely a violation of that definition, which had said that every x value can be assigned exactly one y value. Well, 4 is assigned to 2 different y values. So this is not a function. And it's one of the x values, in this case 4, is assigned to 2 different y values, in this case 18 and 21. Number 5, now when we're looking at a graph, there are infinitely many points plotted on that curve. So what we learned that we could use to check function or not function is the vertical line test, which says if you take any vertical line and scan across your graph, it's a function unless you hit 2 points on the graph at any given time. So no matter where I am with this vertical blue line, I'm only hitting 1 point of that curve. That means this is a function. Again, whenever we're saying yes, we do have a function, we justify that with the definition. So each domain element is paired with exactly one range element. Please don't give as your reason the vertical line test. That might be how you determined that it is a function, but the reason that you know it's a function is because you figured out that each domain element is paired with exactly one range element. Okay, number 6, 6 and 7, we are going to use this graph of f of x. There's no real world context here, so it's just a line segment. Okay. So why does this graph represent a function? Once again, if you're uncertain, test it with the vertical line test. So there is never a place along that graph where my red vertical line hits 2 points. It is always hitting 1 or even at some places none, but 1 or fewer points. So therefore, it is a function, and it's because, again, each value of the domain is paired with exactly one range value. Are the variables discrete or continuous? And give a reason. Now, if you remember, discrete means they are not connected. There are not values between the individual points of the graph. Continuous means they are connected. So this one is a continuous graph. The reason is that the endpoints of the segment are connected. All the points between one end and the other count. They exist. So there are no jumps in the graph. Okay? The endpoints are connected. What is f of 3? Now, in this function notation, the number in the parentheses is always our x value. So if we want to know the value when we go to 3 along the x-axis, that's 1, 2, 3. Read up my graph, 1, 2, 3, 4, 5, 6. So that point is 3, 6. So the value f of 3 is 6. For what value of x does f of x equal 2? Well, now this 2 over here is the y value. So when I go up along the y-axis to 2 and look, hey, where's my graph? It's over here, 1, 2, 3 to the left. So f of -3 gives me a value of 2. What is the domain of the function? Well, domain is asking me to list or express all the x values. Well, it's not all real numbers because this graph does not go left and right forever, infinitely. It starts here and ends here. So where is that? That's from -1, 2, 3, 4, 5, 6, 7, 8, 9. It starts at -9, continues to 1, 2, 3, 4, 5, 6, +6. Now, everything between those values So everything from -9 to 6 has a value. So -9 is less than x is less than 6, and I just have to choose, do the endpoints also count? Is there a point at -9? Yes. Is there a point when x is 6? Yes. What is the range of the function? Again, since this is continuous, I'll need an inequality, and that is from the lowest value, the bottom of the graph, which is at -2, to the top of the graph, which is at 1, 2, 3, 4, 5, 6, 7, 8. So it goes from -2 to 8, from the lowest value to the highest value. From -2 to 8, we are now talking about the range, so f of x. And again, I ask myself, do the endpoints have values? Is there a point on this graph with a y value of -2? Yes, there is. Is there a point on the graph with a y value of 8? Yes. On what interval is f of x? Now that's like saying the y value. Where is the y value greater than or equal to 0? Well, the y value is 0 here. And then it stays greater than 0 for this part of the graph, all the way from this purple point to the end of the graph. So on what interval? Well, that interval started here at 1, 2, 3, 4, 5, -6, and it lasted till the end of the graph, which we had already said was at 6. So we'll give our intervals on the x-axis. It's from -6 to 6. Now, as far as including these, that's all about the way the question is written. We want to know on what interval is f of x greater than or equal to 0. Well, at -6, it is equal to 0, so that counts. And at 6, it is greater than 0, so that counts. On what interval is f of x greater than 4? Well, greater than 4, let's see, and that's a y value. Where's the y greater than 4? I go to 1, 2, 3, 4 on the y value, and it's greater than 4 up here. However, it's not greater than 4 right here where it hits the y-axis. It is exactly 4. This wants to know when it's greater than 4. So that interval goes from 0 to the end of the graph at 6, but we do not include the 0 because when x is 0, the value is not greater than 4. When I get to 6, is it greater than 4? Yes, so I include the 6. Okay, now let me clear all my mess off this graph so we can do number 7. So number 7, we are just converting back and forth between coordinate and function notation. So the point in coordinate notation, 6, 8, would be written as f of 6 is equal to 8. The second one, f of -9 equals -2. Well, when I convert that to coordinate notation, that's the point -9, -2. All right, now we have a little more work on the last two rows because we don't have any of the notation complete. So this third one here, when the x value is -6, 1, 2, 3, 4, 5, -6, there's my point. The y value is 0. So first I have to finish the coordinate notation and say that point is -6, 0. In function notation, I write it f of -6 equals 0. For the last one, I have nothing in the coordinate notation, but half of the function notation. And since it's not the number in the parentheses, but the value on the right over here, then that means it's telling me the y value is 6. So on the y-axis, I'll go 1, 2, 3, 4, 5, 6. Look over to where my graph is, and that is the point 3, 6. So that in function notation is f of 3 equals 6, and coordinate notation, of course, is 3, 6.